friends, welcome back to another video. This is question bank number 4, which means we are discussing questions from the chapter of laws of motion, and the grind for BITSAT 2025 is on. Previously we have discussed question bank 1, 2 and 3 of the respective chapters. If you have missed out on those, of course you can check it out once you finish with this video. Okay, so you know the drill about this video. Firstly we'll discuss the important topics and the question weightage, the previous year question weightage from this topics. But first of all, I would like to tell you that if you haven't started yet, start now. Okay, this is the right time. Your mass competition is going to come in 2-3 months from now, and they'll go around with this videos. Okay, if you are starting now, you will have a great advantage over there. Okay, and also you have this dream, right, of getting into the BITS colleges. So I'll start working consistently towards your dream. Okay, the right time to start is now. Make this the right time, don't wait for the right time. Okay, with that little motivation, let's come back to the series. So first of all, we'll discuss the weightage across the topics. Now for this chapter, laws of motion, I'll highly recommend that you don't go by this weightage, since one question can test more than two concepts. Okay, there is a overlap in the concepts, as you shall see in the question. So but since it's the trend of the series, we'll discuss this. Okay, but don't stick rigidly to it. Okay, questions are being framed from two overlapping concepts. Okay, so from equilibrium there were 3 questions. From equations of motion there were 6 questions. So force equals ma. Okay, you have to balance free body diagram, and F equals ma you have to do. So those type of questions. Then constant motion also is included over there. Okay, so pulley, and you have the strings, tension. Okay, so then friction is one of the favorite topics of BITSAT. Or in that also block over block is favorite. On that I have one separate video, how to solve block over block questions. So if you are interested in that, you can check out that video. So friction also we'll discuss a few questions. Then pseudo force, then on the concept of circular motion. Okay, so this comes in 2D and here also sometimes. And then we have questions on conservation of momentum and energy star, because this will come in the next chapter also. We are going to discuss ample amount of this type of questions in the next chapter also. Okay, so with the weightage being told, let's begin with the questions. To question 1 and 2 for the day. So question 1, we have a body of mass 5 kg. It is suspended via 2 strings making certain angle with the horizontal. You are supposed to tell what is the tension T1 and T2 in the strings. Okay, so basically you'll have to resolve these tensions and balance the forces, right? This is in equilibrium. So downward force is its weight, so 5g or 50. I'm taking g as 10. So mass into gravity basically. Okay, then we'll resolve this T1 and T2. T2 will be so opposite to theta. Remember that it is sine theta. So opposite to theta is the vertical component. So we'll have T2 sine 60. So similarly here also we'll have T1 sine 30 opposite to theta, and along this horizontal will be the cos component. Okay, so that will be T2 cos 60 and T1 sine cos 60. Okay, so now we have to balance the forces horizontally and in the vertical direction also. So let's balance this forces. T2 cos 60 should be equal to T1 cos 60. Okay, sorry, this should have been 30. What am I doing? Okay, so this is 30, right? The angle is 30 over here. So cos 60 is sine 60 is root 3 by 2, cos 60 is half. So here it is root 3 by 2 cos 30, right? So T2 is root 3 times of T1. Okay, here also in the options you can see B is the only correct, right? T2 is root 3 times of T1. Okay, so but we'll carry out the whole thing. We'll find the values of T1 and T2 explicitly. Okay, so question was framed differently in the book, but I have framed it differently, so it makes it simple. Anyways, we'll balance the forces in the vertical direction. So we have T2 sine 60 and T1 sine 30, right? So that should equal to 50, the force in the downward direction. T2 sine 60 is root 3 by 2, sine 30 is half, and we have 50. So we can take this 2 to the other side, so that will make it 100, and you can substitute T2 as root 3 times T1, right? So that root 3 and this root 3 will become 3. Okay, and 3 and this one Okay, this will become T1, right? So 3T1 plus T1 will have, right? Root 3 and 3, root 3 will make it 3, and this will be 4T1 as 100. So T1 is 25. T1 is 25, meaning T2 is root 3 times of 25, which is 25 root 3. Option B is correct. Okay, so basic question on balancing the forces, obtaining equilibrium. Then in question 2, we have applied some impulsive force for a sphere of 500 grams. Now you will see the options in kg, so we'll convert that in kgs. So this is one of the important things. Whatever your answer is in the units of, you make sure that you convert your units in the question to that particular units of the answers. Okay, so you don't get a wrong value. Okay, so they can play around with that also. So here we are given that the acceleration is that, mass is given, acceleration is given. We can tell what is the force. So here we are supposed to tell what is the gain in the momentum. Gain in momentum is nothing but force in time, right? That is how impulse is defined, force into time, right? Because dp by dt is force. So force into time will give you change in momentum. Okay, or I shall write dt. Okay, small time. You'll see that time is around 0.5 seconds, right? So this is simple. You are given the acceleration, the mass is given, so mass is 0.5 in kgs, and force is mass into acceleration, so that is 10, and dt is around 0.5, right? 0.5, 0.5, or you can have 2.5, right? 0.25, and then multiply by 10. So that in the SI unit is option A. Okay, make sure you convert the units and be careful around the units. Okay, so those are the first two questions. Over to the next one. 3 and 4 over here. In question 3, we are being tested for the concept of pseudo force. So here we have a simple pendulum which is hung from the ceiling of a train. The train might be in motion, we don't know. So here it makes certain angle, and it is in pointing in the direction in front of the train. Okay, it's inclined in front the direction towards, okay, towards the front. Okay, this is some theta we can say. Okay, now you are supposed to tell what is happening to the train. Is it moving with constant velocity, accelerated motion? Is it retarded? Okay, so that your pendulum is pointing in the forward direction. Okay, if you know the concept of pseudo force for an observer in the non-inertial frame, like an accelerated frame. Okay, so this can't happen for constant velocity. So this is an accelerated frame. Okay, it can be accelerated or retarded. We'll find out. So for this observer, what is the acceleration on the simple pendulum? First of all, it's acceleration due to gravity g in the downward direction, and he's also seeing an acceleration in that direction, right? But what does the concept of pseudo force says? Actually, usually we have the train moving, right? Suppose we have the system moving, and then if we want to observe something in the frame of the system, we opposite this, right? We opposite the direction of this acceleration, and we apply it to the object of our interest. Suppose there is a block, we apply the acceleration opposite. Okay, so here also we'll have to make the acceleration opposite and apply it to the train. Okay, so we are just reverse engineering this. So if you are in a non-inertial frame, you just reverse the acceleration of the system and give it to the system that you are observing in the non-inertial frame, right? So similarly, if we are observing this is the acceleration in the non-inertial frame, we have to go out, reverse its acceleration and give it to the system. Okay, so this is the acceleration of the train. Okay, so the train is moving forward, but its acceleration is opposite. So basically it is retarded motion, right? Acceleration opposite. Okay, so here we have retarded motion being happening to the train. Also you can picture it intuitively, right? So the train is coming at a stop, so it's moving forward, right? So your pendulum is making that angle because the train is coming to a halt. It is retarded. Okay, so intuitively you can also see that. Now the spring in question 4, we have springs, only one spring. Its lengths are L1 and L2, okay, for forces of 4 Newton and 5 Newton respectively. So if you apply 4 newtons, it will stretch by L1, 5 newtons, it will stretch by L2. Okay, you are supposed to tell the natural length. In fact, you can do this question if you just note this. F is kx, right? K delta x, change in the basically the displacement from the natural length, and this is the spring constant. Okay, also of course there is a minus, but we are concerned about the magnitude. Anyways, we are going to take ratio, so that is going to cancel. Okay. Anyways, if you know this, you are good to go. You can do the math, but if you see force and your this k is constant, so there will be an inverse relation. Okay, if you see between the length and your stretching. Okay, length and so this will come, 5 will come with L2, 4 will come with L1. Okay, so opposite, sorry, 5 will come with L1, 4 will come with L2. Let's do the calculation, it's confusing. So F is equal to K. For the first case, we can write how much it is stretched. It is stretched by L1, right? Total new length is L1. Okay, when you apply a force of 4 newtons, the length becomes L1. So L1 minus L, right? This is the natural length. This is the length when 4 newtons is applied. So similarly, this is F1. F1 we know it to be 4 newtons. Okay. Similarly, for 5 newtons, which is F2, K will remain the same spring, right? And then this stretches by L2. Okay. Total length, total stretching is L2. Okay. Total length when you apply 5 newtons. Now the natural length, so that will give you this delta x, right? So that is L. So this is the amount actually stretched. So the total length minus the natural length. So that will give you the stretching, right? So that is that delta x. Now you can take the ratio. This will be 4 by 5 L1 minus L upon L2 minus L. Now you can solve and obtain L, right? That is what we want. So 4 L2 minus 4 L1 is 5 L1 minus 5 L. So L I can bring on this side. Have I done? This is it. So L I can bring this side. So 5 minus 4. So that will give me L. 5 minus 4L, right? 5L minus 4L, that is L. And 5L1 minus 4L2. So that is what I was saying. So 5 for L1, 4 for L2. Okay. Direct relation. Sorry, I was saying opposite, I think. 5L1 minus 4L2. That is your correct choice. Let's move to the next question. Into question 5, we have 3 masses, M1, M2 and M3. They are adjusted like this. So masses are equal. So basically we can use M, M, M. Okay. One hangs freely. This is frictionless pulley. Okay. But the this floor is not frictionless. It has a friction coefficient of 0.25. Okay. You are supposed to tell what will be the downward acceleration of this block M. Okay. So now it's basically you have to apply equation of motion. Okay, so basically we can treat this two block as one block of mass 2m, right? So I can write in place of this one block of mass 2m. Since they are connected by a string, it's massless. Okay, so here there will be tension forces T and T, but they are internal and they will cancel out each other, right? And the friction is not different for the two. Okay, masses are same. So here the friction is not different, so we can treat those two blocks as one block of mass 2m. Okay, so that is what we are going to do just to simplify our case. So we have 2m over here and m is the pulley. So here what is the force on 2m? So here on m it will be tension force and its weight mg, right? And here also we'll have tension and tension force. Okay, and then we'll have this friction also acting, right? It's moving in this direction. There is a downward motion as specified by the question, so it's moving in this direction. Friction will be opposite. Okay, so friction in the opposite direction, and there is mg and of course 2 mg we can say, and the normal force. Okay, so this will need for calculating friction, right? So for this block we can write T minus mg or mg minus T, because the net motion is in the downward direction. So mg minus T is mass into acceleration, right? Force is equal to net force is mass into acceleration, law of motion. And then again you have to apply that over here. So T minus Fs, so T is greater in this case since the motion is like this. T minus Fs is mass into acceleration. Mass is 2m to acceleration a. So here also you can see that both the two blocks m and m will move with the same acceleration, right? It's constant motion, so there is no use of treating them differently. Okay, Now let us solve this. T minus Fs you can calculate. This will be mu n, right? And n is nothing but 2 mg. So 2 mu mg. So that is your Fs. Okay, n is 2 mg. You can see. Okay, so 2 mu mg, and you have 2 ma. Okay, so you have these two equations, and what are the variables you want? Basically the acceleration, so you want this a. Okay, t and a are your variables. Okay, so this is equation 1 and 2. T and a are your variables. We can add these two equations. T will cancel out and we'll get a, right? So we'll have mg minus 2 mu mg. So I'm adding 1 and 2. So t cancels, mg minus 2 mu mg. Then this 2 will get added. So that is 3 ma, right? So m can cancel out throughout. And what are we left with? Something similar? Yes. So you can take this g common, 1 minus 2 mu, and divide this by 3. So you get acceleration, right? So which is option C. So quite simple. You just have to apply simple logic and your equation of motion. Net force is mass into acceleration. So that's about this question. Over to the next ones. Question 6 and 7. In question 6 we have a block and which is placed on a surface. There is friction between them. We are supposed to find the coefficient of friction if it is given that it is acted upon by force P and force Q as shown. Q makes an angle theta. P is horizontally upward, right? So we are supposed to tell what will be this coefficient of friction so that this block remains in equilibrium. Okay, so we will have to balance the forces so that this block remains in equilibrium. Okay, so first of all we'll have the weight mg in the downward direction. Q we can resolve. Q makes an angle. Q is like this, right? So along theta, now this is theta. Okay, now with the vertical, so opposite to theta is this, right? So this will be Q sine theta. I told you opposite to theta is sine theta, and adjacent to theta will be cos theta. Okay, so this is for Q. We have resolved Q. So Q will be here we'll have Q sine theta. So also you can see the intuition, right? Q is pushing the block like this. So it's a component is in the forward direction and the downward, forward and the downward, right? So Q sine theta and Q cos theta like this. Then we'll also have normal force from the contact between the surface and the block. P force is also there. P is like this, right? So in order to stop the motion, we'll have friction in the opposite direction, Fs. Okay, so these two forces and this should cancel out in each other so that the block will not move. And of course, the vertical forces will also cancel. So we can write N is equal to Q cos theta plus mg, right? I'm balancing the forces in the vertical direction. N is equal to Q cos theta plus mg. Also, Fs has to be equal to P plus Q sin theta. And what is Fs? Fs is mu n, right? This will be Fs is mu n, and n is, as we know, this, right? So mu into n. So Q cos theta plus mg. Okay, from here we'll get our answer P plus Q sin theta. So mu is nothing but P sin theta, P plus Q sin theta, P plus Q sin theta. So P plus Q sin theta upon Q cos theta plus mg. Okay, P plus Q sin theta upon this thing, right? Upon mg plus Q cos theta. You can fill it up. Okay. So option A is the correct choice over here. Now question 7. Some of you, all those who are preparing for boards, will already know that this as a formula. Okay, so a car of mass m is moving on a circular track, level track. It's not banked, and the radius of the track is r. Coefficient of friction is mu s. Then you are supposed to tell the maximum speed. Okay, even if you don't know anything, you can apply dimensional analysis over here. Okay, it should work. Yeah, it will work. Okay, so if you apply dimensional analysis, you will see that only this formula has the correct dimensions of that of velocity. Okay, so also we'll work it out, and some of you might know it as a formula, right? Vmax is under root mu rg. So we'll work it out. It comes from balancing the centripetal force, basically your friction on the between the road and the car will balance this centripetal force. Okay, so this is balanced by mu n, and n is mg, right? N is mg, so m and m will get cancelled. V is nothing but under root mu rg, or mu s rg in this case. Okay, so option D is the correct choice. It is also a formula that you can remember, the maximum speed for a car moving in on a circular track. Okay, provided it's not, it is leveled. Okay, it is horizontal. So that is about question 6 and 7. Over to the next one. Question 8 and 9. In question 8 we have a box on one of a plank. Okay, so this plank is raised slightly up to it reaches an angle of 30 degrees. When the box starts to slide, okay, slip and slide, it travels 4 meters in 4 seconds. You are supposed to tell the coefficient of static friction mu s, and also that of the kinetic friction mu k. Okay, so first of all, it is also given in your NCERT that this mu s, static friction, is the highest value of your friction and it should be always greater than mu k. Okay, sometimes in practical cases it might be equal. Okay, so if you have this in mind, you can say this will be not my option. Here if you see mu s is less than mu k, again this cannot be my option. So only viable choices are this, wherein mu s is greater than mu k, right? So we'll find out. So we'll have to treat 30 degree as our critical case at that point. So it is a point where the block will just begin to slide. Okay, so we'll consider 30 degree at once we'll consider it to find mu s, and once we'll consider also 30 degree to find mu k. Okay, it's not controversial. It is a point where the block just begins to slide. Okay, so at 30 degrees, basically we are saying that what is the force along the incline? Along the incline it will be mg sin theta, right? Along incline mg sin theta, opposite to the incline mg cos theta. It's opposite to the resolving case, so keep that in mind. So this is theta. Along the incline we have mg sin theta. Okay, so this mg sin theta, will say it's balanced by the static friction. So Fs is mg sin theta, right? So we'll say mu s and normal force, and keep in mind over here that the normal force will not be equal to mg in this case, right? It will be mg cos theta, perpendicular to theta, or perpendicular to the incline is mg cos theta. Okay, parallel to incline is mg sin theta. So here mu s and n will be mg cos theta, right? And we'll have mg sin theta. Mg can get cancelled. Cos theta, we can use the 30 degree case, right? Cos 30 is root 3 by 2, sin 30 is half, 2 cancels, mu s is 1 by root 3, which gives you a value of around 0.57. Okay, so we'll use it as 0.6. Okay, so also tell me why this is used. Okay, 4.0 and 4.0 seconds. Okay, why is that used? There is some logic behind it, and there is the logic why I'm keeping it to that term, right? 0.6, only one decimal after the, I'm giving too much. Okay, one decimal after the one digit after the decimal place. Okay, tell me why I'm doing that. Okay, why it is explicitly also mentioned in the question. What is the logic behind this, or what is the concept behind this? Okay, so that is the answer that we get. You can comment about that in the comment section. So for static friction, this is the answer that we get. What about kinetic friction? Now kinetic friction will assume that the block is moving again at 30 degrees, because this is a very critical case. At this point the block just begins to move, right? So we'll apply both the cases to the same angle. So here we have motion, so here the friction is kinetic, and we have mg sin theta, so no longer we can use here also there is some acceleration, right? So we can use the second law of motion. Here we just balance the forces. Here we'll have to use net force is ma, right? So we can minus from mg sin theta, we can remove this friction. That will leave us with the net force, right? This is the net force, this minus this, the motion is downward, which is mass into acceleration. Okay, now how do we find this acceleration? We can find this acceleration from the data that is provided over here. So we have been given the distance and the uh, um, time, right? So we can use s is equal to ut plus half at square. U is initially 0, right? The block was at rest, slowly it was raised. So at that initial point, okay, just before sliding, it was at a halt, right? So we'll use u as 0, so half at square. So half this, okay, substitute it down. This is 4, this is half. Acceleration we are supposed to find, t is also 4, right? 4 into 4, t square. So this and this can get cancelled, this and this will get cancelled. A is half, right? So 0.5 meters per second square. So we get the acceleration, okay? That was needed to substitute over here, okay? So let us find now. So mg sine theta, mg sine 30, right? Half. So this friction will be mu, and again we have mg cos theta, right? Mg cos theta, so root 3 by 2 again, and cos 30, right? Yeah, I think it's correct. And mg, so we have, again we can write this as half, and m is m, so m by 2 can cancel out throughout, right? So we'll have g minus g root 3, or I can write it as 10, g is outside, 1 minus root 3, there is mu is over here, right? And this is 1. So g I can substitute as 10, and from there we'll obtain our answer. 1 minus mu root 3 is 1 by g, which is 0.1, okay? And this minus 0.1, so 1 minus 0.1 is 0.9, so 0.9 is mu root 3, and you'll have to divide this mu 0.9 by root 3, so you'll get to the answer that you got, okay? So you'll get the answer to be somewhere around 0.5. So once you had gotten this, you could have directly marked this one, right? Because this cannot be the correct cases, okay, as we have discussed the logic. So here, coming to this question, we have a block of mass m, which is in contact with the cart as seen. This has some acceleration alpha, okay, the cart has some acceleration, and now you are supposed to tell what should be this alpha so that the block does not fall down, okay? So mu is given as the coefficient of friction, okay? What should be alpha such that block does not slide down, okay? Mu is of course there, otherwise it will fall down. So here, going in the frame of the cart, we'll use the concept of pseudo force. We have to change the direction of the acceleration and apply to the block, right? So alpha will be in this direction once we go inside the cart, okay? So from the cart's perspective, it's like it is not moving with angulation, acceleration alpha, rather the block is coming towards it with acceleration alpha, right? So also we'll have this, so we can write the forces m alpha, right? Mass into acceleration, mg also will have, and friction is balancing this mg, and this results in the normal force. So that's why this will result in the normal force alpha, right? So this will contribute to your friction. So greater the acceleration, so greater the normal force, and that will contribute to friction, and that will help to balance this block, okay? So that is how the physics is physicsing over here. So Fs should equal mg. First of all, let us find n. N is m alpha, you can see that. So we have to keep this block in equilibrium, right? So balance the forces, let it not fall down. So Fs is mu n, so mu times of m alpha. This should also equal to mg, right? For the block not to slide down, friction should be greater, right? Friction should be greater than this force that is in the downward direction, or at least equal, so that it is just about to slide, okay? It won't slide, just about to slide. This and this will cancel, and you can find alpha as something greater than g by mu, okay? Alpha should be greater, it can't be smaller, since it can't be, so this is some positive value, alpha can't be 0, right? If alpha is 0, that block will fall down. So this was anyways not the option. Here you can see option C, right? Alpha should be greater than this ratio, so that you can balance the block, okay? So those were the question 8 and 9. Over to the final question for the day. And the final question for the day, kudos to you if you have made it this far in the video. So here we have 3 blocks A, B, C. Masses are given 3m, 2m, m. okay, respectively, then the value of acceleration of block A, the moment string, the string is cut, okay, between A and B. So once you cut the strings, there will be no strings attached. Okay, lame joke. So here A, what will happen once you cut the string? The the tension on the block A will just vanish, right? Once you cut the string, there is no tension as such over there. Okay, so here what will happen? We'll have Fs prime. Okay, so here I've used Fs and here it is Fs prime, the spring force due to the first spring. Okay, so that will be in the upward direction. Of course, we have mass mg in the downward direction. Okay, so what has happened, there was initially also t in the downward direction. Now that t has gone, right, t has gone. So basically here there will be an acceleration in the upward direction, right, because the t that was pulling in the downward direction, the A block was balancing these blocks as well, right. Now that t is gone once you cut it, so there is some imbalance, right, that t is gone, so there is more force in the upward direction. Fs was balancing t plus mg initially. Now that t is gone, so Fs is more, so it will spring up, okay, with some acceleration that, which we are supposed to find. So let's analyze the block B and C also. So initially there was T over here, that T will vanish. Once we cut the string, there will be some mass, so 2 mg, since the mass of the block B is 2m, and also spring force Fs for this spring, okay. So this is also over here, right, just like this is over here also, okay, just like the string. So these are the forces on B, okay, and let's come to C. C will have, of course, 3 mg in the downward direction and Fs, right. So what can we do? We have to find the acceleration of this block. Okay. So Fs prime was balancing T plus mg, right? Fs prime was balancing T plus mg. Okay. If we can find T, okay, here also there was T, right? So in this case I'm speaking. Oh, okay. So Fs prime is balancing T plus mg. For B, what is happening? For B, we'll have T is balancing its weight 2 mg plus, also there is a Fs prime, right? And finally, this is for A, B and C. Okay, A, B and C in the initial case, wherein they are in equilibrium. So C is being balanced by, so the weight of C, which is 3 mg, is balanced by R Fs. Okay, so I think this is Fs, right? Fs. Okay, this spring. So this is balanced by Fs. Now we can reverse substitute. Fs is 3 mg. So tension is 3 mg plus 2 mg, which is 5 mg, right? So we have substituted this over here. T is 5 mg. Now again you can substitute this over here. So Fs prime, you get it as what is that? So this is the spring force. Okay. Once you cut the spring, it is same, right? Spring force will not change. The tension becomes 0. Spring force at the instant directly will not go to 0. Okay, not instantaneously. So substitute this 5 mg over here in T, so you will get 6 mg. So this is the spring force of the first spring. So Fs prime we have. So Fs prime minus, so we'll use m net force is equal to ma. Okay, so Fs prime minus mg, the weight of the block, is ma. So F net is equal to ma. So we know that the motion will be in the upward direction, right? Because the force is more over there. So initially it was balancing these two forces. One is gone. So this is great, right? So if you drop T, Fs is greater than mg. Okay, so you can also see that Fs prime, whereas Fs prime is 6 mg. If you drop 5 mg from here, Fs prime is of course greater than mg, right? So yeah, math does not lie. So here we are supposed to find the acceleration, right? So Fs prime is 6 mg. Okay, am I doing something wrong? Okay. So this is 3 m, right? Force, net force is mass into acceleration, right? Net force is this. Mass of the block A is 3 m. Okay, keep that in mind. You might make a mistake. So mass of the block is 3m. First of all, the options are not very nice. You can see they are saying the motion will be in the downward direction, right? Acceleration or 0. That only option you are left with is G. Anyways, we'll prove it. So this is mg 3ma. Okay. Again, is there some issue? I think 5 by 3 I'm getting. Let me check. Oh, I think I did a mistake over here. C block has weight mg, right? C block has weight m. So this is mg. So Fs is balancing mg. Okay, so accordingly we'll change. So mg, once you substitute over here, this will become 3 mg. That is the tension. Okay, so this is 3 mg. Now Fs prime is 3 mg plus mg, which is 4 mg, right? 3 mg plus mg, 4 mg. Okay, now we can solve. 4 mg minus mg is, so that is 3g, and here also you'll have 3a, 3 gets cancelled, g is equal to a, and that will be in the upward direction since that force is more. Okay, so option B, G in the upward direction, is the correct choice over here. I hope you enjoyed today's session and it was helpful. If you haven't watched the previous question banks, or if you want to discover more about BITSAT, we have the question bank series or even the mock test series. If you want to give mock test, or we have the ACE series, which is one of the famous series. It's one and only series of BITSAT wherein we have discussed previous year questions. So if you are interested in any one of that, go to the playlist section and check out for yourself, explore for yourself, start learning today, and I'll see you soon in the next video. Till then, keep enjoying physics.